Good day. Today's lesson is all about the laws of exponents. Now, boys and girls, you may find that some textbooks say there's 6 or 7 or 8 laws. It doesn't matter. But it's actually, according to me, there's basic 3 laws and then there will be 2 bylaws. So let's start with the explanation and keep up with me. Right, the first one. If I say 2 to the power of 3 times 2 to the power of 4, let's expand it first and see what happens. So it will be 2 times 2 times 2 for the 2 to the power of 3, and then 2 times 2 times 2 times 2 for the 2 to the power of 4. Careful, that dot, that point means it's multiplication. It's not a decimal, it's multiplication. Right, now if I have a look at this now, the expanded form. How many 2's have been multiplied with one another? 1, 2, 3, 4, 5, 6, 7. 7 2's were multiplied with one another. So then I can say my answer will be 2 to the power of 7. 2 to the power of 7. Now, boys and girls, if you look at the question and you look at the answer, isn't there maybe a shortcut that you can see? Yes, there is. Can you see that to get to the 7, we said 3 plus 4? Yes, and this is the first law of exponents. So let's have a look at it. The first law says bases must be the same. It's all about the base. They must be the same. So x to the power of a times x to the power of b. Bases are the same. And what happens with them? They are being multiplied. Okay, so what do you do with your exponents? You add them. So my answer will be x to the power of a plus b. I know this looks weird, but you will get used to that. So that's my first law of exponents. If bases are the same, they are being multiplied. What do you do with your exponents? You add them. Let's have a look at the second law. If I have a calculation that says 2 to the power of 5 divided by 2 to the power of 3, I can write it in expanded form. So 2 times 2 times 2 times 2 times 2, divide by 2 to the power of 3. 2 times 2 times 2. You agree? Okay, and now we can start cancelling out. So 2 can go into himself once. It can go into that once, and here once, and once. Okay, we've cancelled out. So what's remaining? 2 to the power of 2, because there's 2 2's. So it's 2 to the power of 2. And because it's in the numerator, it stays in the numerator. Now, boys and girls, have a look at this now. If you have a look at your question and you have a look at your answer, and you keep the first law in mind that said, if bases are the same, they are being multiplied, I'm adding my exponents. What will then happen if bases are the same and now I am dividing the bases? What do you think we should do with the exponents? We should subtract them. And you can see that if I said 5 minus 3, my answer would have been a 2 in the exponents. So, and this is our law. The law says, if I have x to the power of a divided by x to the power of b, I can first say it is x to the power of a divided by x to the power of b. It doesn't matter how you write it, but the bases are the same. They are being divided. So what do you do with your exponents? Subtract. How? The top minus the bottom. Or in this case, the first one minus the second one. So my answer will be x to the power of a minus b. And that is my second law. The third law, have a look at this one. If I have 2x cubed to the power of 2, that's my question. And now, how would you have written this? We can write this maybe because it's to the power of 2, I can write my bracket twice. Yes. So I can say it is 2x cubed times 2x cubed. And now I'm back with the first law that says bases are the same. They are being multiplied. So what do you do with your exponents? You add them. Boys and girls, how many different types of bases do I have here? It's all about the base. I have a 2 and I have an x. That's my base. So you need to add the exponents of the base 2 as well. So 2 to the power of 1. And there's a 2 to the power of 1. Yes, bases are the same. They're being multiplied. So add the exponents. So it's 2 to the power of 2. And the y's, or the x's, x to the power of 3 times x to the power of 3 will be x to the power of 6. X to the power of 6. Now, if you look at the answer and you look at the question, isn't there maybe a shortcut that we could have followed? Yes, actually there is. You know what's the shortcut? I can say, if I have an exponent outside my bracket, I can multiply the exponent with all the exponents inside the bracket. Let's do that. So this is actually to the power of 1, and now I can multiply the exponents. 2 to the power of 1 times 2 is 2, and x to the power of 3, 3 times 2 is 6. And can you see that we get the same answer? Yes. So that is my third law. Let's write it out. The law. It says x to the power of a, y to the power of b, everything to the power of c. I have 2 bases inside of my bracket. So what do? Multiply the exponent outside the bracket with the exponents inside the bracket. Okay, so that will be x to the power of AC times y to the power of BC. And that is my third law. Boys and girls, very important. Remember, this, what I said here, exponent outside the bracket being multiplied with the exponents inside the bracket. You never ever, I can make this a song, you never ever multiply an exponent with a base. No, you only multiply exponents with one another if you are working with your third law. Please remember that. Okay, and how about the next challenge? If I give you a bracket, x plus y squared, everything in brackets square, I said you multiply the exponents outside with the exponents inside. So would you say that the answer here will be, let's see, okay, so it's x squared plus y to the power of 4. Would you say that's the answer? Unfortunately, not. That is not the answer. You know what, boys and girls? The third law of exponents only apply if you have one term in the bracket. Very important. So this is not the same. They are not equal. Actually, how will we solve that? We can say it's the bracket times itself. And once you know that, you have a binomial, 2 terms, times a binomial, 2 terms, and then you do it according to FOIL. If you can't remember, go back and watch that video. Then you do it according to FOIL. Right, so now we have our 3 laws. Let's get to the bylaws. Okay. I will keep numbering. Let's make it number 4. How about a question that says x to the power of 3 divided by x to the power of 5? Have a look here. You agree that that's actually my second law of exponents? Yes, bases are the same. They are being divided. And because they are being divided, what do you do with your exponents? You subtract them. How? The first minus the second, not the biggest minus the smallest. So this will be x to the power of 3 minus 5, x to the power of -2. Okay. How about we write this in an expanded form first? Let's say x times x times x, because I had x to the power of 3, divided by x times x times x times x times x, because it's 5x's being multiplied with one another. Let's cancel out. 1 and 1. Going to that 1, 1, 1 and 1. Okay, so what's remaining? I have x squared remaining. But where is that x squared? In the denominator. So I have x squared remaining in the denominator. And now we got two different answers. What now? Boys and girls, have a look. I have a negative exponent as one answer, and in my other answer, I have the answer in the denominator. So what does it mean? These two answers are actually the same. If I have a negative exponent, I can leave the answer as a positive exponent. And careful, because the teachers actually ask that a lot. It's standard that you should leave your answer in terms of positive exponents. So I have a negative exponent. How can I change that to become a positive exponent? By moving the base with the exponent to either the denominator, if it was in the numerator, or if it was in the denominator, to move it to the numerator. And then careful, just make sure that you change that value. So 1 over x squared is exactly the same as x to the power of negative 2. That's the first bylaw. Let's have a look at the last one. Okay. How about if I say x to the power of 4 divided by x to the power of 4? Again, it's the second law of exponents that we can apply. Bases are the same. They are being divided. What do you do with your exponents? You subtract them. Have a look. So I can say x to the power of 4 minus 4 is x to the power of 0. Do not forget to write that 0. It's very important. If you leave out that 0, your answer actually means to the power of 1. Okay, but this is now a bit difficult. Why do I have a power of 0? Let's do it in expanded form and cancel out and see what happens. So x times x times x times x divided by x times x times x times x. And now if we cancel out, okay, it goes 1 and 1. Can go into that ones and ones, ones and 1. Oh, it seems to me that the answer is 1. But I had x to the power of 0 when I did it in another way. So boys and girls, what now? And that is the second bylaw or the fifth law, what you ever want to call it, that if you have a base to the power of 0, your answer is actually a 1. So these two answers are actually the same. Anything to the power of 0 will give you an answer of 1. And we have proven that because it cancels out. But there's an exception. 0 to the power of 0. It's not 1. It's not 0. 0 to the power of 0 is actually undefined. It is undefined. Boys and girls, I do hope that you understand now the laws of exponents and the bylaws, or whatever you would like to call that. But it's very important that you know them and you apply them correctly. Until next time, goodbye.